simplifying expressions. So we're still applying these properties, and this first one says 7 times the quantity of x plus 2 plus 4. And as you listen to the way I say that, I'm saying 7 times the quantity x plus 2. And I kind of drop my voice down. In doing so, communicating that that closes a parentheses, plus 4. I want you to repeat that 7 times the quantity x plus 2 plus 4 to yourself, just so you get that practice of how to say these. To simplify these, in this particular problem, I want to get rid of my parentheses. So 7 is being multiplied by x. 7 is being multiplied by 2. So if I have 7 x times, or if I have x 7 times, that's 7x. And then 7 times 2 is 14. I won't bother writing that as 7 times 2. Now I've dealt with this entire parentheses and cleared it out, and now I'm going to add 4. Now if this quantity of x was 10, I'd get 70 and then another 18 over here. If it was 100, it would be 700. But this quantity of x cannot be combined unless I know what x is. So for here, and I combine like terms, I'm rewriting 7x plus 18, and this is finished. I'm done. I can't simplify it any more than that. We'll get more practice with combining like terms in later sections. So again, a like term, for two things to be alike, it has to be the same letter. So in that case it was x, and the same power. And in this case it was the power of 1. So because 18 does not have any x's with it, we cannot combine like terms. Okay, now for this one, I'll rewrite this in a different order. It says x plus 3y plus 4x minus 6y. I scan through as early in the alphabet as possible. Well, x is earlier than y. I see x, and I also see 4x. In these early ones, it's nice to rewrite them in the orders of the variables that are accompanying them. And I re-look through this again. Do I see anything else with x? I don't, so I can move on to a different letter, which in this case would be y. Okay, let's rewrite plus 3y. And then I have minus 6y. Well, both of these terms have x's with them, so they are alike. I don't need to, but I can see it if I want to. There's a 1 in front of that x. So if I have x one time and then another 4 times, I have it 5 total times. Well, there's 3y and 6y, but it's 3 minus 6, so the result is going to be to subtract 3y. I always want to check it again and again and again. Well, can I simplify this anymore? I cannot, so I have 5x minus 3y. X is a totally different number from y. We have no idea what they depend on, so those are not like terms and therefore cannot be combined. Negative 2m plus 4n minus 6m. Now if this really bothers you, you could go in and replace m's with x and n's with y's and then substitute it back, because sometimes people get thrown off by that. But we're going to just do this the way I talked about. Okay, earlier in the alphabet, what do you see, M or N? Well, M's earlier in the alphabet. Sometimes people like to show triangles around these. If you do, make sure that you don't just put it around the letter and number, but also the symbol in front of it. So when I look at this, I see 1, 2, 3, 4 separate terms. And I have negative 2m, and I look through the left to the right, and I see another m, so I do minus 6m because I have to bring this subtraction symbol with it. I also see plus 4n. I scan through. Do I see n happen any more times? I don't. But then I see something without a variable attached to it, minus 2. So I have 3 separate types of terms. One's with m, one's with n, and one that is just a constant. I have negative 2 minus 6 becoming negative 8m. 4n just gets rewritten minus 2. Now the weird thing is, this is 3 terms. Our original problem had 1, 2, 3, 4 terms. Often that can feel wrong because it feels like we didn't really simplify all that much. I mean, going from 4 to 3 is not a huge impact. But believe it or not, this is as far as we can take this problem. This is totally simplified. Okay, now you remember how I told you that it has to be the same power and the same letter? I'd like you to try this on your own and see how you do. I'm going to put the results up in just a moment. Okay, 2x squared plus 8x squared partners up, and there is a positive in front of that 8, so that's why I wrote this positive. Y, and minus 2y show up, and there's a minus out there, so that's why that came with it. 8 and 2 gives me 10x squared, and then you probably don't need to show this step if you're like, well, that's 1 and 1 is 2 minus 2 is, and they could drop out, but I think it's a good idea to show it while we're still learning these. Now 2y minus 2y cancels out, and you're left with just 10x squared. Now, remember how I was talking about going from 4 to 3 terms in the last one? Here we went from 5 terms to 1. Now this definitely gives me the sense of being completed, so this feels more simplified to me. But just like the last one, either one's simplified. This is simplified, it ended up with 1 term, the other one's simplified, but ended up with 3 terms. Now let me point something out. This section is called Commutative and Associative Properties. We dealt with it with numbers. We dealt with it with just the abstract representation. We applied the properties with numbers. And with all this shuffling around and rearranging, hopefully you feel comfortable that these were completely okay being moved out front. These were completely okay being moved later into the problem because thanks to these properties, we can do stuff like that. And if it didn't make sense with basic numbers where I took 3 plus 4 plus 5, well, let me write 7, turning it into 3 plus 7 plus 4 because that was easier, then you definitely need to be talking to your teacher, letting him know that. But if it feels comfortable, that's really what we're doing. We're like, well, I'd rather be able to combine these to get 10. So there's benefits when dealing with just regular numbers. But here, I want to be able to shuffle these around so that I can simplify. Otherwise, I'd always look at the next one and be like, I can't go any further. So that's what you're doing with this. You are applying all these different properties. Now, this is simplifying expressions more, but here we have to write the expression. So it says write and then simplify. Name the property used. So we're back to that naming direction again too. 4 times the sum of A and B. So here's the sum of A and B. Increased by twice the sum of A and 6B. Well, here's the sum of A and 6B. Well, I have to double that. I don't need a times symbol here. You can put it there if you'd like. And since I'm increasing it by that, I'll throw a plus sign right here. There's nothing to describe that we did here. We just turned it into variables. So there's no naming of a property here. But next I'm going to take 4 and attach it to each of those. Now notice that I tried to avoid a word there. Well, the reason I avoided the word is because going from this step to the next one, what we're doing is we are clearing our parentheses, so we are using the distributive property. So I avoided that word for a second just so I could describe what we're doing. Same deal over here. 2 is going to attach to A and 6B. So let me write the left side in blue. Here's 4 times A. But we're not just multiplying by A, we're also multiplying by B, so here's 4 times B. Now pay attention to this plus sign. That plus sign means that the plus is going to attach here and attach there, but there's no minuses happening, so I'm just talking about that to remind you. Here's plus 2 times A. Well, what's 2 times 6? 12. Because it's not just 2 times B, it's 2 times 6B. Okay, now there we've already written our property. Some of you probably would write it in this step instead. That's fine, just as long as it's clear. So now I'm going to shuffle these around. I scan through and I look for the earliest letter in the alphabet. Well, that's 4A. plus 2a. So now the color has changed so that I can match my like terms. And here's plus 4b plus 12b. So I have all my combinable like terms matched up. 4a and 2a gives me 6a. 4b and 12b gives me 16b. And I am done with the simplifying part of this. If you're not sure what I wrote there because of my handwriting, then that means you're either letting the teacher do the work for you or not listening well enough. And you could be distracted or other things. I don't mean to be a jerk, but I'm just trying to encourage you to think about thinking. Like, if that didn't make sense to you, then maybe you fell back a step and you got to repeat the video again. Not the entire thing, but that last part. Okay, so then I have 6a plus 16b, and yes, this is totally simplified. So here we had the commutative property, because we rearranged the addition. And then here, I guess we really just substituted. So you can put substitution, and then maybe a little star or a little arrow. That's the worst arrow ever. Actually, that's not true. That can't be true. It's got to be worse out there. Here's combining like terms as well. We're substituting values in, but we're combining like terms because one had an a, and they're all to the power of 1. Okay, let's check this out. Make this one an OYO problem, but I have to fix some things first. The things that need to be fixed are here. Okay, let me make it clear that's a Q. And also this is plus 8. For some reason, it formatted strangely when printing. Okay, 5 seconds, I'm going to put the answer up. Here's my work. Why don't you pause the video again and check, but don't worry if you put this before the 6R. I just often prefer to see an addition and then a subtraction when I'm trying to combine these. So pause this. I'm going to keep on talking. And to be clear there, I want you to pause it to compare your work so you give yourself time to think about it on your own before I talk over your thoughts. Okay, so here's what I did. I first, distributed. So here's me distributing that 9 and then that 8 to the separate parentheses so that we can clear the parentheses and then be rid of them so that we can combine like terms. They did say to label it, so you would have to label this. In descending order, here's something with a 2. And then here's something with a 1. So when I go and I rewrite them step to step, I'm bringing the parts in a different order. Sounds most like the commutative property. Okay, now here I'm just combining like terms, so I would call this substitution, and then maybe in parentheses, or you can draw an arrow like we did last time, combining like terms. And in order to be a like term, you have to have the same letter and the same power. So since this did not have, you probably caught this before I said anything about it, that should have been a Q. I apologize. You cannot combine this Q squared with that Q because they do not have both the same power and the same letter. This is a double assignment, and the reason it's a double assignment is to kind of make it so that you don't do 22 problems of the same type and then another of the same type. I want it so that it's mixed night to night. So make this homework 1 and then homework 2. This is to be the second homework assignment that goes with that. Beautiful.